Hi, math students. It's Miss Carol again, and we are back for Algebra 1B, Unit 2, Project 2, Lesson 8. And we are still working on quadratic equations or parabolas. And let's go ahead and jump right in. This is all about transforming quadratic functions. So there's a lot here, and we've got 7 questions to do. The community pool holds a contest called Water Wars, where participants have to shoot at a target with a water gun to earn points. Alexi is working on his shot, but he keeps missing. The path of his shot is where the x-axis represents the horizontal distance and the y-axis represents the vertical distance. And the target, and so these are the path of his shot and the target are shown on the graph. So we're going to use our knowledge about transforming quadratic functions to help him hit his target. So here's the graph, and we're going to come back to this many times. Let's just look at a few things on here. The point A here on this graph, right here, is where he's positioned. So right now he's at 0 on the x-axis and 4 on the y-axis. This point T is his target. So Alexi and the target. And that is at 16 and 5. So he wants to hit 16 and 5. Okay. Our function that his shot is, pardon me, our function that his shot is following is f of x equals negative 1/16 x squared plus x plus 4. So that's the trajectory of his shot. Okay. So Alexi realizes that if he makes the same shot but starts from a different position, he can hit the target. Okay. So in other words, we can just kind of move this parabola over such that it goes right through that point T. So there's a couple different ways to do that. And they want to know which of these translations produces a function that passes through that target. So if you will look, I'm going to do this in pink here. If you'll look right here, you can see that our graph goes through the point 15, let's see, this isn't, so this is 16. So 15 and 5, and we want 16 and 5. So this point is 15 and 5, and what we want is 16 and 5, all right? So that means that we can move our x values over to the right. But if you'll recall from this lesson that when you want to shift a function to the right, you have to subtract 1 from that x value. It's kind of a backwards way of getting at it. So this one right here, if we have f of x and we're translating it to f of x minus 1. So the minus 1 will move us to the right. If we plus 1, it takes the whole graph to the left. So it's kind of opposite of your intuition there. So that is one way that we can do it. Another way that we can do this is to actually move the graph up 1. Okay, our vertical shifts are much more intuitive with translations. So that would actually be just the entire function plus 1. So that would look like this, our entire function plus 1. Okay, so those are the 2 different ways we can do this. If we subtracted 1, if it was the entire function minus 1, that would move us down. And if we took our x value and we added 1, that would move us to the left. So these are both the wrong direction from where we want to go. All right. Okay, let's keep going here. Lots of problems, not much time. Okay, so then they want to know which of these functions are produced by the translations that we identified in the previous question. So let's do this super easy one first. If we just add one to the function, that is simply adding that constant value of 1. It's shifting it up by 1. Remember, our initial function was negative 1/16 x squared plus x plus 4. So if we just add 1, we get this g of x right here. Okay, we get negative 1/16 x squared plus x plus 5. So that is that's a really quite easy one. And then the other one is harder. So probably the easiest way to do the other one is to realize that we want this graph to go through the point 16 and 5, okay? So let me just rewrite that here. So I want it to go through 16 and 5. I'm going to look at each of these, and we might not get an exact 16 and 5, but we would get close. I'm going to look at each of these and see if I can actually ever end up with 16 and 5, okay? I know I can with this one. If I plug in 16 for x in the g of x, if I say g of 16, I get negative 1/16 over 16 squared plus 16 plus 5. Then I get, this simplifies to a negative 16 plus 16 plus 5. These cancel out. So I know I have a point here at 16 and 5. That's actually a very good check to make sure that one works. Now the rest of these, I just need to see which one of these will work in 16 and 5, or with the point 16 and 5. So all of these negative 1/16 x squareds are going to simplify to a negative 16, okay? So for this first one, I'll have negative 16 plus 9 over 8 times 16 plus 47 over 16 is about 3. 48 over 16 is 3, so 47 over 16 is about 3. We're just going to say 3, okay? This one's going to be negative 16 plus 16 plus 3. And the last one will be negative 16 plus 9/8 times 16. And 81 over 16 is about 5. Okay? 80 over 16 is 5, so 81 over 16 is about 5. All right, so this is going to go to 2. So this one becomes negative 16 plus 18 plus 3. That gives me 5. This is negative 16 plus 16 plus 3 is just 3 because these cancel out. And this becomes negative 16 plus 18 plus 5, which is 7. So the answer is going to be this j of x because it gives me the closest to 16 and 5. These two values are the only ones that'll work for 16 and 5. Okay? All right, down to number 3. Which ordered pairs represent Alexi's new shooting location if he follows either of the translations? Okay, so if he moves up 1, right? If he was originally at 0 and 4, and if he moves up 1, then he's going to be at 0 and 5, right? He just went vertically up from 0 and 4. Let me show you on the graph. He will have gone from 0 and 4, and if the entire graph just goes up 1, he will be there at 0 and 5. All right. And then the other point is if he moves over to the right, okay, he'll stay at a vertical distance of 4, but he'll move to an x value or a horizontal distance of 1. So his 2 points, based on those translations, are going to be that 0 and 5 and 1 and 4. So he can either move up 1 or he can move over 1, and that's what those coordinates represent. Okay, for number 4, I just want to give you a heads up that the wording here is a little off. So it says, Alexei notices that if he changes his shot so that the path is wider, he might be able to hit the target. Which mapping statement of the original function represents a dilation that produces a function that passes through the target? The dilation given here, or which mapping statement, is not actually wider. If A gets bigger, if the absolute value of A gets bigger, your function is going to get narrower. So if we were to multiply 1/16 by 5/4 in any of these versions here, our function is going to get taller and narrower, which does lead us to that point of 16 and 5, but it's not wider in terms of a dilation. It's not flatter. It's actually narrower. So let's just be clear on that. And then when we are doing those dilations, it's that A value where you're multiplying the entire function by that A value. And so we just have to determine, okay, is it going to be which one of these two, which one of the first ones, negative 5/4 or positive 5/4, is going to give us that value? And really, because the inside the parentheses doesn't work for the dilation. So we still need our parabola to be downward facing. So the only one of those that we can multiply our original function by and still have a negative A value and thus a downward facing parabola is this 5/4. And I want to show you really quick what those look like. If you're to plug those into a graphing calculator, the red graph is our initial graph, and then the blue graph you can see is going to go through that point approximately 16 and 5. Okay, so that is the dilated second graph. It is narrower and taller. It is not wider. Okay, all right, so that's why that one works. And then if you simply were to multiply 5/4 through that entire original function, this is what you would end up with. 5/4 times 1 and negative 1/16 gives me a negative 5/64 plus 5/4 x, and then 4 times 5/4 is simply 5. So that's why that one works. Which ordered pair represents his new shooting location if he follows that? Well, remember, if you plug 0 in, okay, if he stays at 0, so if we plug 0 into this function right here, we'll get negative 5/64 times 0 plus 5/4 times 0 plus 5. So that shooting location is going to be 0 and 5. Okay, that's all you have to do to plug that in. And then our last question here is, describe which transformation you think Alexei should use to change his shot, and explain how he would accomplish it. And so this is going to be up to you. I personally think that doing a dilation maybe is just changing how he aims. And so then he is going to have to also move up. That seems a little harder than just moving over. I think just moving over one step horizontally, to me, would be the easiest way to do it. But I would love to see what you guys think of this and what you interpret here. So again, I will look forward to your answers. There's not really a wrong answer here, so just give me your best understanding. Take care.